He needs an LCD too, poor little dude. So of course this is alright, see how far you can get with that problem. So you just gotta think, what's he missing? What's he missing? Alright, let me start to catch up with you guys. What's this middle dude need?
X plus 3.
Yeah, X plus 3. This poor dude here,
Needs everything.
he's got nothing, poor little guy. So he needs X plus 3 and X minus 3. Now to be honest, that looks a little weird, right? So what is X plus 3, X minus 3? It's X squared minus 9. That's a lot easier to just bring the X through that, right? I mean, I don't know if you guys see what I'm saying. How do you multiply three numbers together? You pick two of them and multiply them, and then you multiply the third number in, right? So I would do that times that is, I know that's this difference in squares. And now you can bring the X in. So what do you get here in this first fraction? X cubed minus 9x. Now be careful here. So if you want to, watch. I mean, this is a decent way to do this. You make this plus and negative like you know you can ever since Math 88 or whatever. All right, minus is plus and negative. And now you won't forget that that's negative 2, so you get a negative 2x minus 6. I like it. And of course, this guy, he had everything. Isn't that nice for him? Plus 3. So it's all over what?
X plus 3.
Kick-ass. And now it's just put your like terms together. What do you get? You get x cubed minus 11x. You guys see that I would not waste any time trying to factor the top? Why? What's not right? What's not in the right form?
There's no x squared.
It's not a square, it's a cubed. Right? I don't know if you remember this, but the middle power has to be half the first power for me to even try to look at it like a trinomial. And so that's not in the right format to even try to factor it. Am I saying it's impossible to factor this? No. We could actually use synthetic division, but we're not going to. That would be if you go to pre-calculus and you start doing stuff like that. Yeah. Right now, don't worry about it. We're just done. Right there. Yeah.
I missed where you know how there was 2 over x minus 3 in the top, and you flipped it to make it a negative?
So this was minus.
Yeah, originally.
I like it.
But,
So
what happened? You're not supposed to multiply x plus 3 to the bottom?
Totally.
Okay, and then where do you go on the bottom?
It's still here.
Okay, you don't actually, it just stays like that.
Yeah.
It's not X.
Oh, I see. You don't have to. Yeah,
It's not square.
don't multiply the bottom because the last thing you got to do is see if anything cancels. So there's really no reason to
And
re-multiply
then
the bottom.
go back factor.
Exactly. So that's just wasting time, especially if there were like more of these, and you're just, oh my god, no, don't do that. No point to that. Okay. All right. So anybody that has no bottom, they do. It's over 1, and then you have to make sure that that dude gets involved in the whole process. He's got an empty bowl of ice cream. Give him some. Okay. So I was trying to figure out. I was trying to figure out why to do 7, 6 before 7, 5. I think I just do it in the same order. So what I love about the next 2 sections is this whole idea of making the bottoms the same carries through both sections. Now 7-5, there's more than 18 ways to do these problems. So I'm going to show you the primary method, and then I'll show you some different variations on that. So 7-5, as promised, is all devoted to the complex fractions, which are fractions inside of fractions, right? Fractions, if you want to say that. Really, really boring movie. Oh my god, it's 1/2. So we have stuff like this. Here's a really, really basic problem, so you guys get how to do this. What you got, Jeff? I don't know, man. Sure. I like it. Now this one is just so direct, I'm not going to mess with LCD or anything. This is 1 fraction divided by 1 fraction. Is there a better way to write it? How else can I write this? What's a better way to write this?
6 x divided by
And then how can you do that?
just flip it again.
Yeah, exactly. So like we said earlier, I explained why this works, but just multiply by the reciprocal, and then what can you do? Reduce. I love it. Right? So when it's 1 fraction over 1 fraction, well, that's a dumb way to write it. Let me write it the better way, and then I can attack it. So obviously this section is going to have stuff where there's more than 1 fraction somewhere. Maybe both top and bottom. And then you can't do this. Oh, shit. So here, obviously, what happens?
1/3.
Good? Yeah, there'll be 1x left there. So you just get x over 3. Cool. I like it. Kick ass. Real quick word, because I know what some of you guys are going to do. There's something called cross multiplication. There's only one time in the universe that you directly use cross multiplication, and that's when you have 1 fraction equals another fraction. Then you can cross multiply. Nowhere else will that work directly. Why do I keep saying that word directly? Because you could use this if you're really clever and use a modified version of it in some problems, but oh my god, why do that? This is the only time that cross multiplication works. Because I get people right here, they'll say, well, it's 3x or something, and no, things are in the wrong place, because you don't cross, you just multiply straight across, right, when you're doing fractions. I like it. Cool. I just want to nip that in the bud if I can. Nip that where? In the bud. Alright, so what's an uglier version of this going to look like? Well, let's see. Ooh, that was yummy. So, the standard way to do this is to make all the bottoms the same, because then you can kill them. So, you know, real quick, if I have an equation, make a number or something, Jeff, there you go, buddy. Then I can multiply both sides to kill the bottoms, right? If I multiply by 15, I can kill all the bottoms. Is that cool? You guys remember that? All right, I like it. Because I have 2 sides to an equation, so it keeps the balance. Where are my 2 sides here? Top and bottom. Cool. And I can multiply top and bottom by the same thing, and it keeps the balance. So if I make the bottoms, all the bottoms the same, just like I would here, I make all the bottoms 15, because then they would cancel when I multiply by 15. So of course, this one's staring us in the face. What do I have to do? That's over 1, that's over 1, so these both need x. So I just multiply by x. So then I get, what do I get here? I get x squared over x. I might as well do this, because now they have the same denominator, right? Over. And now I know it looks like that, but watch. I could have done this over there too, but that one's just so direct. Multiply, let me see if you guys get this. And again, like I said, there's multiple ways you can go from here. So whatever makes the most sense. But to me, just to make it sort of like the same thing we do with equations, multiply the top and bottom by x. Because what happens then?
Cancel the x.
Yeah. Alright, let me stop there for a second. How are you guys? You guys see what just happened? No. Shit. Where did I... Alright, let me take that away. Let me take that away. Alright. Alright, is everybody cool from here to here? Be honest now. It's okay if you're not.
Not when you do the denominator, I missed that. So that x2 minus 1 over x divided by x plus 1.
Yes, good. So is everybody cool? All I did here was make that over 1 become an over x. So that became x squared over x minus 1 over x squared over x plus 1 over x. That's the direct next step. And then, of course, I can combine those. To be honest, I didn't really have to, but it just kind of puts everything together. Stop there. I really want you guys with me on this. So is everybody cool from this step to this step? And is everybody cool from that step to this step? Okay, cool. And now that you've got the bottoms the same, I can kill them. I mean, this sucks because there's multiple fractions, but all the fractions have the same denominator. So they're really easy to kill, right? It's like all the zombies just lined up for me. Cool. So those go away. Those. Why am I allowed to do this? Because there's a top and a bottom. I'm allowed to multiply top and bottom by whatever I want to. Except here. So then what do I get left on the top? X squared minus 1 over.
X squared plus 1.
Can anybody tell me why there's no reason to go even try to go further with this? Because the bottom.
It's addition.
Good. Beautiful. So this is prime. So I don't care that I can factor that. I can't factor the bottom, so it's not going to reduce. So I just stop. Yes?
Where did the outside x's come from?
Well, let me ask you this. What would you do there? And I love it. You're all like, yeah, you're a politician. I ask you a question. No. Come on. What do you do there?
Multiply times 3.
Where those threes come from? Because that's what you needed, right? So I've got something over something. I can multiply top and bottom by anything I want to. I'm going to multiply by something that actually does something useful.
In order to cancel.
So this is like my 3.
Yeah, but just to cancel.
Exactly.
Oh, I thought it came from other places.
No. So this came from me. That's the problem.
Yeah,
I'm like,
you
man,
actually
problem, you
know
look gross. Let me do something for you, problem. There. All right, now you look a lot better. Yes, sir.
Do you have to multiply the top and bottom by the same thing?
Definitely. Right, this is a fundamental thing about, I couldn't just go, well, I need that times 3, but I don't want to, I'm just going to multiply you by 4.
Okay.
Right? I know when you start doing variables, we start to lose touch with.
So like I was looking at one fraction and one fraction on the bottom.
Gotcha. That's why you can't do this until you get the bottoms the same.
Okay.
I like it.
Why don't you distribute that x like you do in with regular numbers, though? Into
The difference here is that x died. It's not there anymore to go through. So I wouldn't distribute it because that died. I like it. Does that make sense? I mean, there the whole reason was I wanted to make this bigger. So match. This is kind of the opposite. I want to make this small. I want this to go away. I want it to become 1.
Okay.
I like it. Yes?
Why can you flip? Like,
Oh, totally. I mean, so again, The reason I don't is it's less writing. But are you saying this? Why instead of doing this, why don't I just divide by or multiply with a reciprocal or something?
Yeah, how would you do it?
So here's what it looks like right now. So I can rewrite that as x squared minus 1 over x times the reciprocal. Is that cool, just to kind of jump to that? And then you can see very directly that the x's cancel. So if that looks better to you, do it that way. I do it this way because there's less writing. I don't want to rewrite this shit. I just want to directly kill what I don't want and get to the answer. But again, it's all about what makes more sense to you. That, you don't have to introduce some x out of nowhere. They're the internal x's killing themselves. Right? I like it. But, for example, if I have 4 over x divided by 4, that should not be a hard problem. What's 4 over x divided by 4? Without doing any real work. 1 over x. I like it. Because 4 divided by 4 is 1. So if I have 1/2 divided by 3/2, that is 1/3 because the over 2's cancel. So here the over x's cancel. That's a more direct way to do that. Again, if what I said earlier makes sense and what I'm saying right now doesn't, forget about what I'm saying right now. You've got a way to do it. Get a way to do the problem. That's what people, I don't know if you understand that about math. I do problems very differently from some of my teachers. For damn sure. Some of them weren't cool with it and they suck. It's too bad for them. There are multiple ways of looking at math. And that's why we need more people to get into math, because maybe there's some way we haven't looked at it yet that will make some problems easier. I'm only one person. Every math person is only one person. The more people that come into the fold, the more they're like, whoa, let's just do it this way. Holy shit, yeah, let's do that. We need fresh ideas. And you're all like, yeah, you do. All right. I mean, I got a lot of cool ideas, I think, but I'm only one person. I mean, you guys would, who knows, if you knew enough math, and you're like, wait, why are we doing it like this? Oh my God, you're right. Sorry, that's enough of that. Let's do another one of these. Sure. So just to kind of get at what somebody was just saying, if it starts like this, I get the sense that most of you guys would like this anyway. I would agree with you on this problem. It's already just 1 fraction divided by 1 fraction. So like I said on the very first problem we did, you could just immediately multiply by the reciprocal. There's no other real work to do. Does that make sense? I mean, so this is this divided by this, so this is this times. Is that cool? So of course you can definitely just go ahead and do that. So it'd be times. Is that cool? Because it's this divided by this, so it's this times the reciprocal of that, and then what can you do? Yeah, you can factor this. And then this cancels here, right? So just keep y over y is 3. Done. Right? It's only when there's fraction plus fraction over fraction minus fractions, and that's where things get a little bit muddier. So let's try one of those. Ooh, that one looks particularly yummy. Let's try this one.
For that fraction, if we knew the answer, do we still want it to work or the answer? Just looking at it right now, without all the other ones, I can tell it's y over y minus 3.
And I kind of see how, but you'd at least have to show me this. Because then you can see those going away. Yeah. So you do. Almost every problem you got to show me your work. But please, dear God, if the problem is 7 times 8, don't write 7 8s and go, here's your work, Joe. No, I mean, have some. There are some problems that there's just no work to show. I got to let go of those. But in general, when in doubt, show me something. Yeah. Okay. So what about, which one was it? Oh yeah, that one looks gross. Oh, they like doing this kind of thing. All right. Now, of course, the brain might go, kill those, they're gross. Why can't we do that? Yeah, it's part of an addition subtract problem. I can't break into that. I like it. So try to attack that problem. Try something.
So equal by 2.
Whichever way you like better. We'll see what happens. Anybody not get their quiz back? Oh.
Go ahead, Felicia.
Oh. Well, who are you? I know there's more hands. Who else? Anybody? Oh. I'm going to try to show you a shortcut to the method I showed you earlier, so maybe more of you will buy into it. We'll see what happens. Try what you want to teach them. All right. Who's got the answer? What do you got?
3x okay.
Oh.
X plus 1 over 5x plus 1.
Almost. Yes.
Is it x minus 2 over 6x minus 2?
Almost. Sort of.
X plus 2 over 5x minus 1.
Almost. Yes. There it is. Together we have gotten it. I like it. Like if only there were group tests. Shit. Okay. So let's see what happens here. It sounds like if you added 3 and 2 and got 6 or something weird. What's this guy missing? X. And he needs
X minus 1.
He needs. They're like the same problem, aren't they? And he needs the x minus 1. Now watch. Everything has the same bottom, right? So if I multiply the top and the bottom by this, I'm left with 3x. Now be careful here, right? Yeah, minus 2x plus 2 over. I really want you guys to see this. Once I make all the bottoms the same, they pretty much just go away because I multiply by that thing. And then I'm just left with the tops. Over 3x plus 2x minus 2. So then you do get x plus 2 over 5x minus 2.
So, got all that. But, so you know how that one has an x minus 1? Why aren't we just giving that one a minus 1?
So we looked at a problem like that earlier. So it starts off like this. So now watch. It's effectively the same thing as saying, okay, this is, what do you got, Jeff? 3/8 minus 2/7. All right, well, let me just subtract 1, and then that would be 7 also. Does that feel okay?
Got it.
Good. It's the minute we put variables in, we think everything's different now. We think everything's different. So, I can make, if that's a minus 1, I can just give it a minus 1 or something. No. But nothing can change. Variables are numbers. They have to act the same exact way. All the rules that numbers have, the variables have also. They just look different, right? And plus, we're working with things we don't know. That's why when you bring variables in, things get harder. Yes?
So when you multiply by x, x minus 1, it cancels out all the denominators?
Totally, because it distributes. That distributed there, right?
Okay.
And then it die area. And top and bottom of this big ass fraction, so that's why it's legal, because they multiplied by 1. I like it. Maybe. And that's not the only way to do that problem. There are all kinds. Does somebody do it a different way?
I think that's on the bottom. Flip it and then cancel.
So you like, some of you guys, I'm sure, put these together, and then like multiply the reciprocal maybe like we were doing earlier? Yeah. So real quick, I have a feeling that it might be true. Just to show you what it looks like. Some of you guys might have done this. Let's just cut to the chase. On the top, when you put these together, you get the x plus 2 over, and here you get the 5x minus 2. And then you can multiply by the reciprocal. I don't know if anybody did sort of like that. No? Okay, hopefully you did it some way. You got somewhere. Yes, sir.
So, you distribute the negative sign to the 2 and the x and the negative 1.
Totally, because this is plus and negative, so that's negative 2 times x and negative 2 times negative 1. That's why it becomes plus 2.
Yeah, so you only distribute it to the 2, not to the x minus 1 in parentheses.
There's only one negative. So it can only go on the 2, or it could go in there, sure. There's only one negative though. So if I have negative, so I got minus, let me try to capture
In
this.
parentheses, there's 2 sections, so to speak.
Blah, blah, blah. So I can either put the negative on the 2, or I could put the negative inside here. Either way you do it, you're still going to get negative 2x plus 2.
Yeah.
I don't know if that makes sense. Because if I do 2 times 3 times 4, and I say, okay, that's 6 times 8, what have I done wrong? What's wrong there? Is that wrong? Is it? Maybe I'm just pranking you a little bit, huh? Not that evil.
You distribute 2.
Yeah, well, how many 2s are there? 1. So how did the 3 get a 2 and the 4 got a 2? What the hell? So the same thing's happening there. There's only one negative, so either he gets it or he gets it. They can't both get it because there's only one of them. I like it. That kind of happens in a few places in math.
So it's like a negative 1. Right?
Yeah. So make that there's another factor of negative 1 to put in there. I like it. All right. Okay. That's section 7.5. Yes, ma'am.
On the homework in 7.5, there's some with like fractions with mixed numbers. Do we turn? With mixed numbers, do we turn those?
Oh, there's your question from earlier.
Fractions and then.
Which one are you looking at?
15, I guess. Just have a little.
Oh yeah, just change those to improper first.
Okay, and then
Yeah.
just do whatever flippy thingy.
Then flippy thingy. Yes. Such technical language. Okay, yeah, I remember yours. So you had a problem that sort of looked like this here. Actually, I can't remember. Did yours have like? Let me see. Yeah. Okay. I got you. So it's basically like that, right? Okay. Why, Jeff? Because the book did it. I chose it. Too bad. So what's the one thing that's written in the wrong format for what we're doing? Yeah, negative exponent. So what's the way to write this? I mean, this looks nice because it looks like it's just something over one thing, but it's hiding the fact that this is what? How do I rewrite this? What flips? What's being raised to the negative power? Good. So that would be 2 over x. Now, why can't I just take this up? Right? That's an excellent question. Let me desperately try to explain why. Stay with it. Everybody understand the question I just asked? And some of you guys might have had that question. And you're like, why are you making this so hard, Jeff? Just do like you said before. But the problems we did before, I don't know if you remember this, the only operation that was in them was multiplication. That was it. Oh, this plus screws everything up. It always does when you're trying to work with exponents over addition. It's never going to be pretty. So when remember this kind of thing, I had like 5a8 over 6b to the negative 2. And what did we do? We brought the b negative 2 up. Now let me just show you. Again, that's actually a shortcut. It's sort of related to why we multiply by the reciprocal. Stay with me now. B to the what power would be 1? What power would I have to put on b to make it become 1? 0. B to the first power is b. B to the 0 power is 1. So what I have to multiply, how many b's do I have to multiply by here to make this become 0? Do you see that? Now, won't that make 0 now? Alright, let me stop there. Absorb what I've written there. And I'm not saying you have to do it this way now. I'm showing you a different way of thinking about it that will help us with this. Because it is true that the negative means flip. So, but look, wouldn't I have just normally taken that straight up? Didn't what I just do accomplish that in a little more explanatory way, to be honest? That's why the two b's go up, because to make the bottom 1, I had to multiply by b squared. That's sort of related to how why you multiply by the reciprocal, why that process works. Now again, when I do this kind of weirdness, when I explain something to you, if you really, really want to, just tune me out. I'm fine with that. But I'm trying to show you deeper why things work. So here, if I wanted to move that up,